Okay, so now this is going to be reading when stars explode. When you look and it doesn't give you any hints, it's going to be important. I mean, it does say look for these words and make sure you know what these words mean. Observe, inward, and reactions, and we will underline that. But I know, just kind of knowing you students as I do, that you guys would kind of flip through this and try to see what questions you're going to have to answer. So we want to make sure that we underline what we think our two main ideas are and two key details as well. Just so that when we get to this part, we don't have to reread 3 or 4 times. We just have to read it 1 time. So, back up to the top. Let's read through, make sure we're out underlining 2 main ideas and 2 key details, as well as underlining observe, inward, and reactions. So that means if we do main idea, that's one thing to underline. But there's 2 main ideas and 2 key details. So we're underlining at least 4 things plus these 3 keywords. So we're going to underline 4, 5, 6, 7 things. A lot to underline. Okay. When stars explode. So when I read that, I'm thinking, okay, everything I need to underline is about what happens when a star explodes and what an explosion is. Okay? So a supernova is a spectacular death of a star. So that's what it's called when a star explodes. The last time people saw in our galaxy was 1604. That was before astronomers used telescopes. However, every year astronomers see a supernova exploding in other galaxies. So it hasn't happened here, but it's happening other places. They can observe them for months before they fade into view. Most supernovae, come from massive stars, okay? That's important. It's not telling us about an explosion. It's a massive star. It is born with 8 times the mass of the sun. That's a very big star. Astronomers can often observe. I'm just underlining that because we said we were going to look for what observe means. So if it says they can observe supernova, they are sitting there looking at supernova. So we're going to underline it, and then next to it, because you always have to annotate, observe means to look at closely. So you can write that in your margin, however you want to write it. Now observe is done. I'm going to strike it through. Inward and reaction are left. It's a massive star, 8 times the mass of the sun. All right. When it is young, it is hot, bright, and blue. Its center makes energy the same way the sun does, by changing hydrogen, the lightest element, into helium, the second lightest element. All right, so they're making energy. This nuclear reaction, okay, that's one of our words, reaction, creates energy or heat that makes it shine. Alright, so I'm going to underline because we said reaction was another one. This nuclear reaction, and it's saying that a reaction is a change. Look, there's changing hydrogen into helium. A change from one element to another. So reaction is a change from one thing to another. Okay, because reaction can be used in more than just science, but it's definitely used in science. So now we can take reaction out. We just have inward. Alright. The outflow of huge amounts of energy, much of it light, pushes outward from the star's center. That's good because the force of gravity pulls inward and tries to make it collapse. So that's our last word to be looking for, is inward. If it's pulling it inward, that means basically they're pulling it inside. To pull inside. Okay, now we have our 3 new vocab words. You can put that anywhere you would like to. But as long as a star can make energy, it can fight the force of gravity and survive. So we're just finding out that they make energy. But how did they make energy? So it makes energy by changing hydrogen into helium. And this nuclear reaction creates energy. Alright, so I'm glad that we highlighted this, or underlined it. I'm also going to highlight it because it's also answering one of our main idea questions. This is a main idea as well as following the directions for learning about the different words. So it's going to be a very important sentence later. So nuclear reaction creates energy that heats a star, and that's what makes it really shine. Okay? But as long as a star can make energy, it can fight the force of gravity and survive. However, a massive star must make lots of energy to fight the gravity of its own mass, so it will shine very brightly. So if you see a star shining brightly, that must mean it's going to die. As a result, we can see the star hundreds of light years from space. Wow. And then they're talking about the distance. These are all like details, but none of them are key details yet. But because the star shines so brightly, it uses up hydrogen fuel within millions of years, much less than the billions of years the sun will take. So, the sun's not going to be exploding anytime soon, but these shining stars will. Okay? Soon a star can run out of hydrogen, expands and cools, and then it becomes this red supergiant right here. I'm just trying to remember my main idea is what is a supernova and how do these stars make their energy. So now it's saying how stars make their energy. A red supergiant makes energy by changing helium and other elements into heavier elements. Underline that. That seems very important. These nuclear reactions don't make as much energy as hydrogen, and then it runs out of fuel. Now the star is in big trouble. It can't make energy. The star collapses. You see it's collapsing here, and then it's blowing out pieces into space. The star has exploded. Okay? Supernovas are violent, but we don't have to worry. Okay? If it happened like close to Earth, we would be in trouble, but the nearest star that will explode currently is more than 100 light years away. But the supernova actually helps life. Earth would not exist. So when the universe began, it only had 3 elements, hydrogen, helium, and lithium, but life needs heavier elements like oxygen and iron. So the Earth is made up of oxygen, silicon, and iron. Almost all oxygen came from these massive stars. So that's how we can breathe, is because the star exploded. During their lives, massive stars cause helium to join to make oxygen. When stars explode, they cast oxygen into space, and the explosions themselves make iron. So they think that supernova explosions made all of the universe awesome. A star needs fuel to make the energy that fights the gravity. Alright, so what is a supernova? A violent explosion of stars. So let's go back to the beginning, because one of our questions is what is a supernova? So we can underline this because it's a spectacular explosion of a star, spectacular death of a star. And then the other main idea we have, so let's make sure both of our main ideas are highlighted so that we don't get confused when we're looking. Okay, so we have our 2 main ideas, and we need 2 key details to go with that. So how does it make energy, and when does it occur? Like, are we in danger, basically? So, the center makes energy. Okay, so we're looking through. Which one's talking about how the center makes its energy? Doesn't make energy. Alright. This one, if it occurred, we'd be in trouble. That will help us. And then we want to make sure, how does it make its actual energy? So I remember it saying it's similar, making an energy to the sun. There we go. It makes its energy this way. So we'll underline that. So when you're looking through, just so you see, this is a main idea, this is a main idea, and these are our key details. You always want to make sure you have 3. So astronomers can observe supernova for months is a key detail. Its center makes energy the same way sun does by changing hydrogen into helium is another key detail. And then the force of gravity pulls inward and tries to make a star collapse. And this is kind of the same thing. It's saying helium is changed. And if it occurs within a few dozen light years of Earth, we would be in trouble. Alright, now we're going back. What are the 2 main ideas? So 2 things that we highlighted. Supernova are a violent explosion of stars. Yep, we highlighted it's a spectacular death of a star, very similar. So yes, I will highlight that as a main idea. Astronomers did not always use telescopes. That is a fact, but it has nothing to do with stars. So if we're talking about exploding stars and they're talking about telescopes, that's not what we're talking about. Astronomers can see them for months. Kind of important, I won't cross it out yet. Stars make energy through nuclear reactions. Yes, because look, we highlighted, if you go back to the beginning, we highlighted nuclear reaction creates energy. Okay? So when we come back down here, we're going to highlight it. And that's the 2 main ideas. Now that we have that, the other one, stars produce light. No, we're talking about supernova, not stars. Supernova are interesting. That's an opinion. I will definitely even cross this out because anytime you see an opinion and you're talking about main ideas and facts for a science article, you don't want that. 2 sentences that support it. The last time people saw a supernova, that was before they were using telescopes. We already talked about how telescopes are not what we're looking for. Such a star is born with 8 times the mass of the sun. Science fact, but not necessarily about, as these are our 2 things, that they're violent and that they have a nuclear reaction. This doesn't say violent or reaction. This doesn't say violent or reaction. But it does say exactly how it's created. It makes energy. So that goes with stars make energy. It makes energy. So if you can connect it, I'm connecting D with D actually. Interestingly enough, that doesn't always happen, but it happened here. As a result, we can see a star? No. If they occur within a few dozen light years, we would be in trouble. Well, we did say they were violent, and we did highlight that we would be in trouble. Those would be the 2 that you would want to highlight. Alright, read the following sentence. But as long as a star can make energy, it can find the force of gravity and survive. What best defines energy? So reread the sentence and kind of think of what you would think of in your own mind. So, but as long as a star can make energy, so something that's giving them the ability to go on, and what we have to figure out, what is that? Energy is not always physical strength. Hydrogen, helium, gas, heavy metals. Okay, it's definitely not heavy metals. And it's not physical strength because a star doesn't have physical strength. We're talking about stars. They do have hydrogen, helium, gas, and they do have power that comes from heat. So which one is what gives the energy? Is it hydrogen, helium, gas, or power that comes from heat? Okay, so I don't see if there's hydrogen and helium as an element, but does that give it energy? So let's go look at energy. This is how it makes energy. How does it fuel energy? Power that comes from heat.